Imagine transmitting data at the speed of light without any cables or wires. Sounds like a science fiction movie, right? But it's not. Welcome to the world of optical free space communication. This fascinating technology is all about sending information across vast distances using nothing but beams of light. Picture a message encoded into a ray of light beaming through the air, across the atmosphere, and even beyond, to satellites in space. Unlike traditional methods that rely on cables or wires, this is communication on a whole new level. It's like taking a letter, turning it into a beam of light, and sending it zipping through the sky. Now, you might be asking, how does this all work? Well, in the simplest terms, optical free space communication is like giving light a message to carry, and it zips away at 299,792 kilometers per second. So how does optical free space communication work? It's all about lasers, modulating light signals, and receivers. To begin with, we'll dig into lasers. These are not your average supermarket checkout lasers. We're talking about highly concentrated beams of light that can travel great distances without dispersing. These lasers form the backbone of optical free space communication, acting as the carriers of information through the air. Now, you might be wondering how these lasers carry information. This is where the magic of modulating light signals comes into play. Imagine you're at a concert, and the intensity of the lights is constantly changing with the rhythm of the music. Similarly, in optical free space communication, the intensity, frequency, or phase of the laser light is changed or modulated to represent the data being sent. This could be anything from a simple text message to a high-definition video. But how do we ensure that this modulated light reaches its destination? That's where receivers come into the picture. These are specially designed devices that capture the modulated light signals. Think of them as a catcher's mitt, waiting to snag that incoming baseball. But instead of a baseball, they're catching beams of light. Once the receiver catches the modulated light signal, it's not over yet. The receiver then has to demodulate or interpret these signals back into the original data. This is akin to translating a foreign language into one that you understand. The receiver effectively turns the light signals back into the data they represent, whether that's a text message or a streaming video. This entire process, from the laser emitting the modulated light signal to the receiver catching and interpreting it, happens at incredible speeds. We're talking faster than the blink of an eye, allowing for real-time communication over vast distances. So, just like a postman delivers your letter, these modulated light signals carry the data from one point to another in the blink of an eye. Now you're probably wondering, where do we use this high-tech communication method? Well, optical free space communication, or OFSC, has a wide range of applications. Let's start from the top, literally. In satellite communication, OFSC allows data to be transmitted over enormous distances at the speed of light. This is crucial for real-time communication with satellites orbiting Earth and even for deep space exploration. But it's not just about the big stuff. Let's bring it back down to Earth. You know those handy remote controls you use every day? Or the laser pointers used in presentations? They all utilize OFSC. A beam of light is sent from the remote to the device, carrying the instructions within it. This might seem mundane, but it's actually a testament to the versatility of OFSC. So every time you change the TV channel with your remote, you're using optical free space communication. Who knew, right? Like any technology, optical free space communication has its pros and cons. One of the key advantages is speed. With light traveling at around 300,000 kilometers per second, it's hard to beat when it comes to fast data transmission. Plus, this technology can securely transmit data over long distances, making it a superior choice for applications like satellite communication. However, it's not without its challenges. Atmospheric interference can distort light signals, reducing their quality or even blocking them entirely. Weather conditions like fog, rain, or snow can pose significant obstacles. Moreover, optical free space communication requires a clear line of sight between the transmitter and receiver. Any obstruction, even a bird flying across the beam's path, can disrupt the data transmission. Despite its challenges, the advantages of optical free space communication make it a crucial part of our modern communication systems. So, what does the future hold for optical free space communication? Well, it's a bright and shining landscape of potential. Advancements in technology and research are opening up new possibilities for this revolutionary form of communication. One promising area is the development of drone and satellite-based communication networks. These could bring high-speed, light-based communication to remote areas that are currently off the grid. Moreover, researchers are also exploring the use of quantum mechanics to create more secure, efficient communication networks. Just imagine harnessing the power of quantum entanglement to transmit information instantaneously, no matter the distance. Furthermore, with the push towards space exploration and colonization, optical free space communication could play a pivotal role in establishing interplanetary networks. These are just a few of the exciting directions optical free space communication could take. As we continue to innovate and push the boundaries of technology, the possibilities for optical free space communication are endless.